Welcome, my name is Dr. DrWedding, and this is DrWedding DC01. Course Introduction and How to Take Notes. The first part of this video will list the major topics that will be covered in this video series. This will help you decide if this playlist is going to be useful to you. The second part of this video will cover a suggested method on how to take notes in this online course. This method will help with any course you take, not just an online course. This series will cover the following topics related to DC circuits. These topics are often covered in AP high school courses, first-year electrical engineering courses, and in electrical engineering courses for non-majors. This course is also geared to an individual with little or no experience with circuits who is trying to learn the topic on their own. If you are taking a course in DC circuits this semester, you may want to compare the syllabus topics to the topics covered in this video series. The series starts off covering engineering notation and its counterpart metric notation. You will learn how to read the color codes on a resistor and learn to read the numeric code on a surface mount resistor. This will be followed by learning about a few types of variable resistors. Voltage, current, and resistance are explained in easily understood terms. Ohm's law is then used to demonstrate how they are interrelated. Once you have an understanding of current and voltage, the difference between conventional current flow and electron current flow will be explained. This is followed by an explanation of how AC and DC are different. The last introductory topic is how to create a schematic using standard electronic symbols. This is necessary because the rest of the course will use schematics. The first type of circuit that will be analyzed will be the simple series circuit. Simple series circuits will then be used to explain the voltage divider rule and Kirchhoff's voltage law. Next, power is introduced. You will use these calculations to determine how much power each resistor is consuming and what size resistor you will need. Opens and shorts are covered and are used to explain how a switch works, and they are used as an introduction to a parallel circuit. Parallel circuits are covered, and you will learn to find all of the unknown values for the circuit. This will be very similar to a series circuit with a few minor differences. You will learn 3 different ways to calculate the equivalent resistance of a parallel circuit. Parallel circuits will be used to cover current divider rule and Kirchhoff's current law. Series parallel circuits, sometimes called combinational circuits, will then be explained. These circuits have the elements of both series and parallel in them. Up to this point, a constant voltage source is used in the problems. Now, a constant current source is introduced. You will learn how to convert between the two sources. Nodal analysis, mesh analysis, and superposition are introduced to solve a series parallel circuit. These methods are more math-based, but they have an advantage over the previous methods. These 3 methods can be used when there is more than one power supply in the circuit. Thevenin and Norton equivalent circuits are covered, and the values from these circuits are used to find maximum power transfer to a load. This course will end with how inductors and capacitors react in a DC circuit. You will calculate and understand the charging cycle, the steady state, and the discharging cycle of these 2 devices. In this second part of the introduction, I will explain how you may wish to take notes in this and any other class. When I was in school, I studied a lot, but over time I learned to study better and not harder. I am going to cover the method I used when I was in engineering and graduate school, and I hope you find this study method useful. Watch the videos in order. The information in later videos assumes you understand the information in the previous videos. Take rough notes while watching the videos, when you are in class or reading a textbook. These notes do not need to be perfect. Just get the key points and copy the examples. Immediately after class, spend 15 minutes to 20 minutes generating a 1- or 2-page summary for each important topic. Don't try to save paper by putting more than one topic on the same sheet of paper. The summary should always follow the same format. The format that I used when I was in school had 4 parts. A title at the top of the page. A brief description of what it will be used for. An explanation of the procedure. and multiple examples. Here is an example of a summary sheet that explains how to read a 4-band resistor. 30 years ago, I used colored pencils and markers to help me organize my thoughts. These sheets were then put into a notebook that I would use when I was doing my homework or studying for a test. Technology has advanced since I was in school, so you may wish to convert your notes into a Word document. This allows you to add diagrams and tables. When writing your explanation, pretend you are explaining the process to someone who has never seen the problem before. Keep in mind, the person you are explaining it to is the future you. By organizing your thoughts into a rigid form, you will force the information into your long-term memory. It will also give you a one-stop shop where you can get an explanation of each type of problem. These notes are also useful when you take the next class in the series. Nothing strikes dread into the heart of an engineering student than hearing the words,
"This information was covered in the last class you took, so I assume you know how to do this."
Lastly, and possibly the most important part, only advance to the next topic when you completely understand the current topic. This may sound obvious, but many students will run across something that they do not understand very well, and they will just skip over it. This causes the student to fall behind in the next class. Now the student needs to learn 2 topics, and as the semester goes on, the student starts to fall farther and farther behind. Hopefully, this video series will help you understand these topics and help you successfully finish your DC circuits course. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This is the only way I can continue to make these videos.